What does NASA's Perseverance rover hope to find on Mars?
And what lies ahead in our exploration of the red planet? Vertical Hold is proudly brought to you by Aussie Broadband, changing the game with their award-winning network and Australian-based support. Hi there, welcome back to Vertical Hold Behind the Tech News, the show where we catch up with Australia's leading technology journalists to dive into the big tech stories of the week. I'm Adam Turner, and I'm joined as always by Alex Kidman, a man who has a nagging feeling that he's been to Mars before. Alex, I warned you about those virtual vacation places. Are you okay?
Look, you're the one who said that I should take a holiday from myself. And look, apart from those weird dreams, I'm sure everything will be totally... God, they're here!
So, speaking of getting freaked out, things are getting pretty crowded around the red planet at the moment. NASA's Perseverance rover is the third Mars mission to arrive this month. To talk us through what's happening with all these missions and what lies ahead, we're joined by Science Alert senior writer Michelle Starr. Michelle, welcome to the show.
Hi, thank you.
Later, we're going to chat about the Perseverance rover with Issa Nesnas, who's the principal technologist and supervisor for the Robotics Mobility Group at NASA's Jet Propulsion Lab. But first, Michelle, tell us about the various missions that are arriving at Mars this month and what they all aim to achieve.
Right, so we've got three. The first is from the United Arab Emirates. They have sent a probe called HOPE, and that's going to orbit the planet, and it will study the atmosphere and the weather, and with an eye towards sort of assessing for a human settlement somewhere along the line, so sending people to settle on Mars. Then we've got China. China is sending an orbiter, a lander, and a solar-powered rover called Tianwen-1. So the orbiter, again, is going to orbit the planet, obviously. The lander will land and sit in place and do science on the spot, and the rover will sort of roll around the Utopia impact basin. They're looking for evidence of life. They're going to look at the soil and the ice. They're going to look at the atmosphere. And they're going to make some maps of that basin region. And last but not least, we have Percy, or Perseverance. That is NASA's rover, and that will be, again, looking for signs of ancient life in the Martian past.
So why are they all arriving at the same time? Why the traffic jam?
Well, that's really easy to answer. It's because, it's easy to answer, but it's hard to do because getting to Mars is actually really quite tricky. In the solar system, you've got a lot of things that are moving around, and the positions of Earth and Mars relative to each other aren't always in the best position for the most energy efficient trip. So about every 2 years, 2 months, we get a window, an optimal launch window for Mars, where it's the least amount of energy required to get there. That was in July to September of last year. So that's when everybody launched their Mars missions, and now they're arriving.
So, Michelle, if I understand it correctly, the Chinese probe, and I love the literal translation of its name, it's something like Quest for Heavenly Truth, which is just beautifully poetic. But as I understand it, it's landing where previous Mars rovers or previous Mars missions have landed, yeah?
That's where the Viking 2 lander went. So, yes, you're correct.
And that was back in the 70s, yeah?
Yeah. So since that time, obviously, our technology has just gone through the roof, where we are so much more technologically advanced now than we were in the 70s. So with the current instruments that we can put on a Mars Explorer, we can learn a lot more than we could learn back in the 70s.
It's interesting. We've got three nations going at the same time. The UAE's a bit of a surprise to me because China you'd maybe expect, because back in the 70s it was all the US and Russia because they were the two superpowers. But it's a bit unusual for someone like the UAE to be sending a probe. Is a broader range of nations now getting into interplanetary exploration?
Yeah, actually, there are. Actually, Australia has its space agency finally. That's finally happening after many, many years of Australia not having a space program. Last year, we saw Israel going to the moon.
India, I think, maybe went to the moon as well. I had its eye on the moon.
Yep, and India also has an orbiter at Mars. So, yeah, it's actually really interesting to see this push for space exploration sort of globally.
A lot of these probes are fairly specifically looking for, well, as David Bowie put it, life on Mars. What's the attraction there?
Oh, well, it's existential, isn't it?
It's the
we
vibe.
we have this wonderful, beautiful, huge solar system, and all the life in it that we know of is just clustered on this one little rock not far from the sun. So we don't know how life happens or why it happens, what conditions it can happen under. If it could happen on Mars, that would tell us something about how we got here. And it would also tell us something about whether it can happen elsewhere in the galaxy and then elsewhere again in the wider universe. That's a fascinating question. I really want to know the answer. Don't you?
Yes. Alex is looking for his people.
You'll find them one day.
Who told you?
So there's been a few Mars missions from NASA since the Viking missions in the 70s. But what are they doing differently this time in terms of looking for life? Like, are they looking in different places or using different technologies? They're not just, I guess, redoing the same thing over again.
Percy is landing in the Jezero crater, which is it's very rich in clay, and there's evidence that it's a delta. So that suggests that there was once water there. And the going theory is that where there's water or where there was water, there's more likely to be signs that life once existed. Percy will be looking for it. Curiosity wasn't really focused so much on looking for signs of life. Curiosity established that the chemical conditions for life once upon a time did exist on Mars. Now, what Perseverance will be doing is not looking for signs of current life, it's looking for signs that there was life once. So it will be taking samples differently, and it will be collecting samples to be returned home to Earth so that we can look at them more closely in laboratories here with a full set of scientific equipment that obviously we can't send up there to Mars.
How they intend to get them back? Are we sending an Uber?
Yeah, world's worst DoorDash.
Yeah. Interplanetary Uber. No, there's going to be another mission where they will send a Mars ascender with a solid fuel that is designed to pick up the samples and then achieve escape velocity from Mars and chuff off home again.
Given the distances involved, has it already left?
No, that won't leave for some years. It hasn't even been built yet. It's not designed to happen until about 2028.
So this is quite long-term science, then. All presuming all goes well with all of these probes, then.
Yeah, you don't go to Mars for quick answers.
So speaking of Percy, as I said earlier, I caught up with Issa Nesnas from NASA's Jet Propulsion Laboratory to talk about what's new and exciting with the rover. And spoiler alert, it has its own helicopter.
So cool.
So this week we're joined by a very special guest all the way from the US. We've got Issa Nesnas, who is the principal robotics technologist with NASA's Jet Propulsion Lab. Hi, Issa. Welcome to the show.
Hi, Adam. Glad to be here.
So all eyes are on Mars this week as the Perseverance rover finally goes into action after traveling almost 500 million kilometers. What does Perseverance aim to achieve on Mars?
Well, Perseverance has a number of objectives, science objectives. One of the key objectives is actually to collect samples as part of a sample return mission. It's also capable, it's carrying a number of instruments to conduct its own investigations of that. Further, it's also carrying a technology demonstration of a Mars helicopter that will be the first helicopter on another planet.
Mars helicopter has to be like one of the coolest phrases in the English language. Putting those two words together is very exciting. And so how long have you been working on this mission and just on Mars missions in general?
So I've been at JPL for over 2 decades, and I've been involved in the Mars rovers over that whole period. Early on, I was very involved in the research, trying to look at mobility systems for Mars. And more recently, I've been exploring an area called extreme terrain mobility, where we want to get into more extreme terrains, because that's where some of the more exciting findings are, but they're much harder to access. And I've been broadening to understand extreme mobility, not only for Mars, but also for the moon and also for microgravity bodies, small bodies such as asteroids and comets.
So that's something that I wanted to ask you about, because I know that the idea with these kind of missions is to try and get into areas that were previously a bit more, that were quite difficult to access. But before we go there, just more generally, what's new and exciting about this mission from a robotics perspective?
So the Perseverance rover is going to have a number of new capabilities. One of the very exciting things about the Perseverance rover, it will have an ability to land within a much tighter ellipse. That is the area in which the uncertainty of the landing of the vehicle. And the reason why reducing the diameter of the landing ellipse is exciting and important is because it allows you to go to more interesting environments to explore, because you don't have to have an area that's very large, that's clear of major hazards. The other thing is that it will have a capability known as terrain relative navigation, which will look at the terrain visually and be able to correct its knowledge of its descent and be able to achieve that tighter ellipse. That's one of the key autonomy capabilities that would be on the Perseverance mission. Another very interesting aspect from a robotics standpoint is it has 2 elements. One of them is the navigation, the surface navigation, which will provide a capability for this rover to traverse a much faster rate in terms of being able to do that autonomously. Of course, the mechanical speed of the vehicle remains largely the same as its predecessor, but this rover is capable. It has more computing and specialized computing to allow processing of imagery to be able to make a much faster pace of traverse on the surface of Mars.
In the past, rovers like this have moved, stopped, had a good think about it, maybe phoned home to check on something and come back. But this can actually think and drive at the same time, yes?
That's right. That's one of the unique elements of this mission, is that it'll be able to do what we call thinking while driving. It's capable to do that because the computing that's on board enables it to process the high resolution stereoscopic imagery to generate a 3D map of the terrain. And then after it does that, it assesses how hazardous the path that it's planning to take. And if that path is planning to take is hazardous, it explores other alternative paths and be able to assess which way to go in a safe manner, all thinking on its own.
So as you said before, as if a rover on Mars wasn't cool enough, Perseverance has its own helicopter called Ingenuity. Tell us more about that.
So Ingenuity is the first interplanetary helicopter. It is a very small package. I think it's on the order of a couple of kilograms, with maybe slightly over a meter wings of its propeller span. And it's what's called, it has dual propellers, coax, one on top of the other. And it is designed as an experiment to fly and take imagery of the surface. So it will have a very nice high vantage point. It'll be able to fly up and move over and then land. And of course, by doing so, it gets a really good vantage point of the site, and that information could be shared with the rover to help in planning purposes. But the rover is not dependent on the helicopter. It will supplement the information that the rover would need.
So I'm trying to picture the initial planning meeting for this, where someone says, call me crazy, but hear me out. What if we had a helicopter on Mars? Like, did this just start out as a pipe dream? At what point did that sort of become clear that, yes, this can be done?
So this is an interesting story that goes back decades, and it's a typical story for technology development. So within the research program, a lot of ideas get explored over decades, and we have a vibrant research program at the Jet Propulsion Lab in Pasadena. But of course, we also collaborate with a number of universities, and there's a lot of ideas that get generated. Now, what happens, a lot of these ideas that get generated are very forward-looking, and at the time they get generated and conceived, sometimes the technology is not there to realize them in flight. And it could be the technology is not mature, or the opportunities are not yet there to fly these things. So this is a story of a technology that was invented in the late 1990s, led by an engineer, Dr. Bob Balaram, who conceived of an idea of to fly on Mars. There were maybe a number of other people, I may not recall at the moment, who may have conceived this concept. And they researched it, they studied it. Now, one of the key challenging aspects of Mars is that the atmospheric density is less than 1% of Earth's atmosphere. So flying on Mars is much more challenging than it is on Earth. And so they studied this problem, and they realized it was feasible. And then it took almost a decade later before the question was asked regarding, could we put something like this on a Mars mission, on the upcoming Mars mission? And the team went in and did some further studies and realized what size helicopter, what size propeller span could enable you to put a helicopter on Mars. And it turns out to be viable.
You mentioned earlier about accessing more extreme terrain. One of the interesting things about this mission is that Perseverance is actually, as if it wasn't cool enough, is going to be lowered onto the floor of a crater using a rocket-powered sky crane, so it can land in the bed of what used to be a lake. Now, I would assume that's because it would be too difficult for the rover to get down there itself. Is this that next step of accessing more rugged terrain? And then what do you think the future is of rovers and other vehicles being able to get to those more harder to reach places when exploring other planets?
Yeah. My sense is we're starting to see more and more evidence of very interesting things that are happening on the non-flat regions of these planetary bodies. And just to give a few examples, several years ago, there was a phenomenon that was observed on Mars crater walls known as recurring slope lineae. And what these were, there were some discoloration that happened that looked like some kind of a flow that appears when the sun is shining on these crater walls in the hot seasons. They fade and reappear seasonally at the warm times. So people hypothesized at one point that this could be, associated with some kind of briny liquid water flows. Now, the jury is still out exactly what's causing these very enigmatic features, but these are happening on crater walls that are 40 degrees, between 30 and 40 degrees in angle. Currently inaccessible to state-of-the-art rovers. That's one example. Other examples, there were some exposed ice stratigraphy that was found on ice caps on Mars at mid-latitudes. There are other very intriguing exposed strata that we see on crater walls. A lot of these, there are crevasses that you see in the polar regions. A lot of times, whether it's on Mars or it could be on the moon, as in the case of, you have cold traps, craters within craters in permanently shadowed regions. Or whether you go to ocean worlds, these are bodies where they're covered with ice, and sometimes you get crevasses, and sometimes you get, vents, certain geological features. All these areas are very intriguing in terms of access for many reasons. Each planetary body has a reason why these become intriguing to access. And having the ability to robotically get into these areas opens up new possibilities for scientists to explore, whether by understanding the layering of this terrain, stratigraphy, or whether being in an area where it could be protected from radiation, as may be in the case of Europa, or whether because they preserve certain ice or frozen hydroxyls, as in the case of lunar cold traps on the moon. They could be interesting for many reasons. The thing that's common among them is that they cannot be accessed with state-of-the-art rovers today.
So if you could build your dream rover, like the forget about the limitations of the technology today, what if you could build the ultimate rover, what would it look like? What could it do?
Yeah, so one of the key things that we're always constrained by when we build space rovers is that the resources these rovers have is very limited. And what I'm talking about in terms of the energy that they would have. And they also are very challenged by the thermal environment. Because of the thermal environment, it could be either extremely cold or extremely hot. It creates a severe constraints on what we can design that would be different from what we design on Earth. But my dream robot, it's a robot that is really capable of scaling these more extreme destinations. Now, we make progress, and there's different ideas of how can you reach these things, whether you can fly a helicopter on Mars and perch on these slopes, or whether you're building a more articulated legged system that can go down, or whether you're rappelling a tethered rover that can be simpler and easily access and deploy instruments on these bodies. There's many ideas. I've been very fortunate to have been involved in a number of such developments. One of them is known as the axial and duaxial rovers, which I can tell you a little bit more about.
So is that something we're likely to see in a future mission?
I hope so. Such a concept has actually been proposed as a mission concept to explore a lunar pit. A lunar pit is a depression, or it's actually a collapse of what is believed to be, it could be a lava tube or some kind of a void where the ceiling collapses and it creates an opening. We do see these on Earth and we see them on the moon. And what's really intriguing about these pits or skylights is that they expose the stratigraphy, almost tens of meters of stratigraphy on the moon. And to be able to go in and access the lava deposits on this wall, JPL put out a mission concept to rappel down that wall using one of the rovers that I've been involved in called the Axial rover. And the idea of that rover is it's very simple. The best way to think about it is like a yo-yo. And if you have a motorized yo-yo, the yo-yo can go up and down without any surface. And this rover is designed in a similar fashion where it has a tether wrapped around its axle, and it's using actuators or motors to turn things and be able to go up and down. Now, when there is a wall, of course, that helps the rover go up and down, resting on the wall, and then taking measurements. And so this rover, it's like a dumbbell, 2 wheels and a cylinder connecting them, and a boom and a tether wrapped around the middle. Of course, when we build it for flight and put all the instrumentation, it gets a little bit more challenging than that. But the fundamental idea is a fairly simple one.
That sounds very cool. So it's almost like a bucket going on a string up and down a well shaft, and then you can stop at any point and look at what you want to see.
Exactly.
Yeah.
That's exactly right. And part of the capability of the system is to be able to orient the body while you're hanging on the tether. So you can place the instruments on the wall. So you can have a carousel of instruments that you can place one at a time on that wall.
Cool. Well, I'm looking forward to seeing that mission in action. But for now, it'll be very exciting to see how Perseverance and Ingenuity perform on Mars. Thanks again for joining us in a very exciting week to talk about what's happening.
Thank you very much, Adam. Pleasure to be here.
So, Michelle, Perseverance sounds really, really exciting, really intriguing. But, I mean, what lies ahead that we know of at this point for Mars in terms of missions?
Well, we have a number of efforts that are currently in development to eventually send humans to Mars. So that's actually extremely challenging to do. NASA's working on that. SpaceX is working on that.
Well, on the SpaceX front, because that's, of course, our old friend Elon Musk, he's made some pretty bold pronouncements about when he hopes to get people to Mars. I think it's something like 2026, which I guess means they'd get there before this rocket that's meant to collect samples gets there, if he's right.
Yeah, look, there are a lot of issues to overcome
You mean
before we
Elon
can.
or the Mars mission?
Oh, look, don't. Well, I'm just not going to even go there with the former. I don't know if there are those issues can be resolved, but getting to Mars, getting humans to Mars, is going to be a lot of logistical challenges involved in that. And I think it might take a little bit longer than a few more years. NASA is, I think, tentatively saying around the 2030s. But just for an example, Issa mentioned the thin atmosphere. So parachutes don't work as well on Mars as they would on Earth. So actually landing people without crash landing them is going to be a big problem because it's going to be a much bigger payload than a rover. So yeah, you're going to have to figure out how to get them down softly. Then there's the problem of radiation. Mars doesn't have Earth's really lovely protective magnetic field that keeps the cosmic rays from constantly pelting us. So there's an unacceptable risk of radiation. So you'd have to figure out where you're going to live on Mars. And realistically, the only place that will protect you from that radiation is underground. Then there's the temperatures. Mars gets really, really, really cold. Mars has horrific sandstorms that just span the whole globe. I don't know if you're familiar with Opportunity. Opportunity was a NASA rover that was solar powered, and a huge sandstorm came up, and all the sand covered the solar panels, and Opportunity could not be contacted because it powered down and couldn't get more power. So, there's horrific Mars weather. There's food, there's water. It's not going to be a simple matter just to, like, it's not like going to the moon where you can just chuff off home again either. It's like a 6-month trip there and back. So,
Well, I think everything I've read on it suggests that whenever that happens, your first set of settlers are accepting that they're probably, risks notwithstanding, they're probably not coming back. Because also that issue of then fueling trips back and things like that as well.
Yeah, well, there is water ice on Mars, so that could be used to create hydrogen fuel. But yeah, again, that would be a big challenge because if you do want to send them home, which NASA does, NASA is planning a round trip to Mars. You have to equip enough fuel to get there and back. So you could park an orbiter around Mars with all the stuff for getting home. So you don't have to land all that stuff, but you do have to get it there.
I would assume that the Chinese are also thinking about this as well, because this is really the same way that the space race was sort of like almost a pride thing between the US and the Soviets as to who could get to the moon first. Is this shaping up as a similar thing between the US and China on who can be the first to set foot on Mars?
I think whoever does do it is going to have, a pretty significant feather in their cap because, yeah, overcoming those challenges is going to take a whole lot of human ingenuity, not the helicopter. Um, yeah, so it could very well be that, yeah, China and the US go head to head on this one, which would be exciting.
What kind of a role in that is there then, as opposed to nation states, for your private enterprise, your SpaceX style thing? What could you do with Mars in a kind of financially stable way? I would have thought the costs involved are not trivial. Are there things you could do?
You couldn't exactly mine it because how are you going to get it all home again? I suppose if you can make the trips round so that people can go there and back and make it safe, you could sell trips to Mars to other rich people, but I can't imagine that there'd be that many of them willing to do
And
that.
it's at least a year. You're talking at least a year of your life,
Yeah,
probably more.
yeah,
That's a lot of
because
in-flight movies.
Yes, it is.
I guess you could do it like they do the Antarctica thing, where you literally you don't land. You fly over it. You say, "I've done this," and then you come back. Would you take a trip to Mars? Understanding the risks and the time factor.
If I could get home, I would. Yeah, I think I would, because I think it'd be really exciting. There are also a lot of health issues that you'd get just from the space flight. Because space is a radiation environment too. And then being in microgravity for a year is hell on your bones. You lose a lot of bone mineral density, so that takes years to recover when you get home. So you'd have to be really committed. I think I would. Would you?
I don't. I'll be honest. I don't know that I would. I don't know that I would without settlement, and I don't see. I mean, I agree with you on the timescales. I think this is work that will be decades in the making, and I think by that stage, it would be a much younger person's game than I will be at that point. But maybe I'm just not adventurous enough. How about you, Adam?
I'd send you first. If you made it back in one piece.
I should have seen that coming.
If you made it back in one piece, I'd feel a bit safer about it. But I think maybe the moon's a lot more practical for that, because Michelle, we're talking about the Artemis missions to go back to the moon in the next couple of years, aren't we? And that's using the Orion spacecraft system, which might be the same one that takes us to Mars. What are we going to see from the moon? And is that a sort of a practice run to getting to Mars?
Yeah, so that was actually going to be sort of like the moon to Mars. It was the NASA mission. So establish a presence on the moon, and then from the moon move on to Mars. So
launch from the moon.
Well, I don't know if it would launch from the moon.
Oh, okay, yeah.
You'd have to get all that fuel up there. But like that was it, just solving the problems to establish a base on the moon would help solve the problems to establish a base on Mars, because they're similar environments. They're both very dry. They're both very cold with extreme temperatures. There's no air that you can breathe. The gravity is lower. There's radiation. So solving those problems for the moon, which is a lot more achievable because it's so much closer, would help develop strategies for establishing a presence on Mars.
And when are we expecting to see the next people on the moon?
I think NASA said around 2024.
So not too far away.
Yeah. I'd go to the moon.
Yeah, absolutely. I just want to go to the moon so I can sing "We're Whalers on the Moon" from Futurama. That'd be worth the trip just for that.
It would. You could wave at Earth.
I'm sending Adam first in this case just to make sure it's safe for me this time. Well, that just about wraps up another episode of Vertical Hold. Thanks to Michelle for joining us for this week's show.
Thank you for having me. It's been fun.
I'm glad you've enjoyed it. And look, as is our usual habit, now is the time for you to answer 3 quick questions. Where can people find your work online? Where can people find you on social media? And which children's cartoon character is the all-time best?
Oh, well, the first 2 are easy. You can find my work on www.sciencealert.com. On Twitter, I'm riding_red. The best children's cartoon character of all time. Oh, that's a really tricky one. Drawing a complete mental blank.
I want to change my vote. I wanted to vote for Krieger from Archer, but I want to change my vote now to Marvin the Martian.
Archer's not a children's cartoon.
This is what I keep telling him.
Don't tell him that. Krieger's my spirit animal.
Same with all the people who keep suggesting South Park characters. They do not qualify.
Oh, I tell you what, Gur from Invader Zim.
Oh, nice. And as always, you can catch us online at Vertical Hold AU on Twitter, at verticalhold.com.au on the web, or via the Vertical Hold Facebook page.
And as always, thanks everyone for listening. Don't forget to tell your friends about us, leave us a review on your podcasting platform of choice, and help us spread the good word in 2021. Vertical Hold is proudly brought to you by Aussie Broadband, changing the game with their award-winning network and Australian-based support. It has its own helicopter.
So cool.
All right, so we'll drop in.
We're
Sorry.
leaving that so cool in there because that's brilliant.
Yes, yeah, right, yes.
You
All
beat
right,
me
so
to
we'll
it.
drop in the interview there.